put 1, 2, 3, and then do the ones on the back that can also be done in Desmos. Remember, with your simplifying or combining like terms, you can check that in Desmos. So we'll do that afterwards. You could have done this one of two ways. Either distributed the negative first. And I'm going to rewrite everything. So this would be plus 4a to the third minus 7a squared minus 5. And then combine like terms. But make sure, it's in order. Highest exponent first in standard form. So your 4a to the third would go first. Your 7a squareds would cancel. And then you just have plus 6a minus 7. So 4a to the third plus 6a minus 7 should have been your final answer for that one. So do use Desmos to check yourself, especially if you have like variables, exponents, something like that. I didn't mention this, but the other way you could have done that is thought about it like subtracting. You may have had to rearrange things. So if you were subtracting it, it would be 7a squared minus 7a squared. They would still cancel out. 6a would still be by itself. Negative 2 minus 5, you would still get the negative 7. And then it's basically 0 minus negative 4a to the third, and it would still become a positive. So 4a to the third plus 6a minus 7 was your answer for 1. Questions on that? Was 2 a function? Yes. You could draw vertical lines through it. It wouldn't pass more than once, so that was a function. Line of best fit, so I'm going to do that in Desmos. That's where you have to make a table. They were different people, so I guess not. Okay, so I'm going to put all of these into the table. I'm going to check this for you. Did it be faster? 2, 14, 4, 6, 8, 10. Remember that if you hit enter on the X's, it'll start to make a pattern for you. But if there's not a pattern, then don't do that. Oh, go on. 10 and 7. Right, and then after you make your table, if you want to see the points, you can hit your magnifying glass. And then you need your line of best fit. So it's going to look like our equation of the line, y equals mx plus b, but not at the same time. So y1, use your squiggly line, your tilde, mx1 plus b. And it's going to give you your m and your b, and you're going to write that as an equation. Y equals negative 0.85x plus 15.9. And that's the line that best goes through that set of data. That will not, those instructions will not be given to you on the SOL. So those are things you have to remember, how to do that in Desmos. Questions on that? I'm not going to do the work for number 4, but I'll check it in here for you. Faster. 3x minus 4 minus 2x minus 6 plus 3 4x plus 8. If you're using the variable x, remember that your x has to be capitalized, otherwise it won't work. Someone tell me the answer you got for 4. 5x plus what? Match. That is the answer. So if you got that answer, good job. You got the correct answer. If you did not get that, go back and see where you made a mistake, because that should be the correct answer. And then the last one, you could have use your y-intercept and slope and graph this line, or use Desmos to help you graph this line. Where you could have graphed by x and y intercepts, but your x-intercept was a decimal, so be careful with that, or count your slope and your y-intercept. Questions on any of those? Everyone should have these notes in front of them. We're going to talk about a different way to factor today. So as a reminder, we talked about GCF, where you have to factor out the greatest thing they have in common, variables and exponents. We talked about difference of squares, where it's a set of perfect squares, and we find the factors of both and put them in two different factors. Here is when we're factoring, I'm going to call them basic trinomials, or trinomials that have an a value of 1. So there's always some invisible 1 in front. These you can kind of think about like puzzles. If you don't like puzzles, I'm sorry. Only one thing works. Only one thing fits. So you have to like find the numbers that work. Yeah, go back to your seats. And there are 2 rules you need to know and remember in order to factor. That when doing this, we're going to look for 2 numbers that multiply to be C. And then of those 2 numbers, they also have to add up or subtract to be B. So we're going to do a few of these. Starting with number 1. So the C value here is 12. So think about your factors of 12. And we can say these out loud.
3, 4, 2, 7.
Missing one.
So there's probably 1.
So of those, if we were to add them together, which one would give us 7?
3, 4.
3 and 4. So for these, if you want to like organize these in a way, I would do it like this. The X is going to be kind of helpful for when we get to our next portion of factoring, not today. I would put whatever needs to be multiplied in the top, whatever needs to be added or subtracted in the bottom, and then the two numbers put in the sides. And the two numbers you found are going to be the two numbers you use in your factors. So you're going to have two sets of parentheses. Just like with difference of squares, two sets of factors, it's just going to look different. Whatever the variable is in your expression is going to come first in both. So that part's the same. But the two numbers you just found are going to be the end parts of it. So if I multiply 3 and 4 together, I'll get 12. If I add them together, I'll get 7. If I were to distribute this back out, so I'll do this one, but I won't do every single one. I should get this original. So off to the side, I'm going to do that. So x times x would give us x squared. X times 4 would give us 4x. 3 times x would give us 3x, and 3 times 4 would give us 12. Just like with the difference of squares, we would still combine our middle two terms, the 4x and the 3x. Okay. So it's really smushed together, but it does say x squared plus 7x plus 12. So that is the original. It did work, and that's how you could double check yourself. Questions on that process before we continue? Let's try another. Number 2. Give me factors of 20.
1,
25, 4, 20 and 1,
10 and 2.
10 and 2. Now, the listing them out is not a necessary thing, but if it helps you see it, definitely keep doing this. So of these, which ones would add to be 9?
4 and 5.
So then we would write our two factors, x plus 4, x plus 5. It does not matter which one you do first. As you keep doing these, the better you know your factors, the easier this is. If you don't know your factors, what you would do is, let's say like for 18, start dividing on your calculator by 1, by 2, by 3, by 4. Keep going until the numbers get either close together or are the same. And that would help you get all your factors. Let's do one more of these and then we'll do a different type. Let's do this one. What are factors of 1? 1 and 1. So it has to multiply to be 1, but add to be 2. So that means the only factors are going to be the ones that we have, positive 1 and positive 1. So we can write that y plus 1, y plus 1. Or, because they're exactly the same, you can write it as y plus 1 squared. Either or. What questions do we have so far? Right. Those were all examples with positive in your expression. Now we'll do some different ones. So let's try 7. Disregard that it's negative for a second. Think about your factors of 18. There's 6 and 3. 1. 9 and 2. And then, because the 18 is negative, the only way to multiply to get a negative is if one of the factors is negative. So we have to go through these and see which one could we make negative so that they still add or subtract to be 3. Which one would be the negative? So I would put in positive 6 and negative 3. And then those would be your factors. N plus 6 and n minus 3. Here, the order of which you put the signs matters. If I put negative 6 and positive 3, it would still multiply to be a negative 18, but it wouldn't add to be a positive 3. Be careful with that. Let's do another one. Let's do 10. 54. Think about your factors of 54. If you're not sure, go on your calculator, start dividing. 9 and 6. Now, I'm going to say that as you're thinking about factors, if you think about the first set of factors like 9 and 6, and those happen to be the same numbers that work for this, you don't have to keep listing out the factors. It may be good for you to do that, but you don't have to do that. Would 9 and 6 work if we made one of them negative? Yes, which one?
6. 6. I didn't know we would. Sorry.
So then what would our two factors be?
S plus 9 and S plus 6.
We'll do one more of these and then go on to a different type. You guys choose between these 4. Okay. So I want you to think of factors of 30, multiply to be 30, but add to be 7, and one of them has to be negative. Think about your factors of 30. One of them has to be negative. And negative 3 and positive 10, that would work. So then our factors, x minus 3, x plus 10. Okay. Some of these will try to trick you. They'll have numbers that look like you should use these two, but when you try to add them together, they don't actually give you that. We'll get into some examples when we get down here. So just be careful. Make sure you multiply them. They do actually multiply to be whatever, and you add them and see do they actually add to be that. All right, before we do some of these, on, do I have this for you? No, I thought I did. Okay. Hold up. I think on the back of your notes, yeah, there's a specific example that I wanted to show you, but I didn't have that up. So we'll do a couple of these. So this is directly on the back of that front page. So the rules are still the same. Have to add to be multiply to be a positive 8, add or subtract to be a negative 6. If I'm multiplying to get a positive 8, will the two numbers have to be positive, negative, a mixture? What do you think? They would either both have to be negative or both have to be positive. Depends. If your middle term is negative, they might both have to be negative. So think about factors of 8. You may have to make both of them negative, where if I add or subtract them together, we get negative 6. Which two numbers would work? If we make them both negative, yes. We have y minus 4 and y minus 2. So be very careful with these type of examples because they both have to be negative. If you make them positive, it won't add to be a negative 6. Questions on that one? Another. Let's do 14. So think about factors of 56. You may have to divide in your calculator if you're not sure what those are. 2 factors of 56. They may both need to be negative. That when you add or subtract them together, you get negative 15. Minus 7 and b minus 8. We're going to flip back over to the front and do a couple more and then move on. So now we have negative negatives. If we're multiplying to get a negative, again, one of them has to be negative. So think about 2 factors that multiply to be negative 63, and one of them is negative, and they both add or subtract to be negative 2. Otis, if you have the answer, hold on one second. Did it go through? Negative 9, positive 7. So b minus 9, b plus 7, or if you write it the other way, b plus 7, b minus 9, that order doesn't matter. If it doesn't work, another couple minutes. Okay. Let's do 18. 2 numbers that multiply to be negative 72 and add to be negative 14, where one of them is negative. 2 is big and it has a lot of factors, so you may have to go through a bit. Negative 18 and positive 4. Leave that way. Do you have any questions in general about how to factor the basic trinomials or when a equals 1? We're going to do a couple other things with this and then switch gears. Let's do this first. On the back page, we're going to look at some of these examples. So this is like a combination of GCF and factoring when a equals 1, or your basic trinomials. Basically, there's going to be a combination of GCF in every single thing. Alright, so think back to GCF. Is there something we can divide out of each of these? And what would that be? 2. For these type of problems, since it's connected to a equals 1, think about how we could get this back to a equals 1. Usually whatever that first number is what you're going to divide by. So if we divide everything by 2, what would be left?
2 minus 2 minus 4.
Okay, so here. Then the process is the same. See if you can find 2 numbers that multiply to be negative 45 that add to be negative 4. Make a smaller x. Yes, over. So with this, leave the 2 on the outside. You would still have your 2 factors. In this case, you really have 3 factors because of the 2 on the outside. So you could write it like that or add an extra set of parentheses here. Either or, doesn't matter.
Doesn't matter. Does it matter?
It shouldn't. As long as they're the same type of parentheses.
I mean, sorry, Khan Academy.
Oh,
Sorry, I got that.
no. Either or should be fine. Alright, we'll do a couple more of these and then change. For number 20, does it have something in common? And if so, what is it? What's something we can divide out of each one? X. So we know it's not a number because the first one doesn't have any. So if we divide each one by x, what would be left? Remember, you're subtracting your exponents as you divide each one. If we had x to the third and we took one out, how many would be left? X squared. What would this next one be? Plus 2x, and then just minus 48. And then we have to look and see, find 2 numbers that multiply to be negative 48, that add to be 2.
Negative 6 and 8.
Yes, that would add to 7.
And you can write that in any order.
Yes. The most common is the GCF first and then either of these 2. You usually won't see this in between or at the end.
Okay. But with the
The
2.
other 2, you can write either first. Yep.
Okay.
one more. Let's do one with a lot of numbers. 21. What can we divide out of everything? Remember, we're trying to get the a value of the squared term back to 1. So 4. And if you divide everything by 4, what would be left?
W equals to negative 13. W.
Then we're looking for what two numbers multiply to be negative 30 that add to be negative 13. Add or subtract to be negative 13. This is one that I was talking about, that it looks clear cut, but it's not. So Otis, you said 3 and 10, right?
Yeah, but that's not right. Right. They're both need to be negative for that.
So that would be an example where, 3 and 10 because 13, and then they multiply to be 30, but they would both have to be negative, so that wouldn't work. So let's think about two other numbers.
Negative. No.
Think about your factors of 30.
Oh, 15 too.
Where 15 is negative and 2 is positive. So be on the lookout for those type of problems where it looks clear cut, but it's not actually because it wouldn't actually work. Do we have any questions on finding a GCF before we do or factor basic trinomials or a equals 1? Regina.
Because they would both need to be negative. For the multiplication to come out negative, we would need both one of them to be negative and one to be positive.
So
Because
this one,
two negatives and one part to the negative positive.
so this one, because it's negative, these could both be negative. Because if I multiply them together, I get positive 30, not negative 30. So what's negative 10 plus 3? So there's only one set of numbers that will work. It looks like 10 and 3 will work, but they will not. Right? Somewhere where you have space, I don't know if you have any space, I need you to write this down. False. You may not need to write that down. I was thinking it was more fraction type stuff, but these are not that. So disregard. Go on to this page. Okay. And then this will be the last thing we do today, and then you have time to practice. Bless you.
Try again. Okay, so of all of our different types of factoring, GCF, difference of squares, basic trinomials, or a equals 1, and we're going to talk about two more. This one will help us do our last one, but it can also be a type of grouping by itself, type of factoring by itself. This type of factoring is the only type that has 4 terms. So if you're thinking about different number of terms, GCF can have any number of terms. Difference of squares only has 2. Your trinomials obviously has 3 because of 3. So we'll do the example and then we'll do a few others. In this, we have to follow these steps. We're gonna group the 2 together, so you can either actually put parentheses around the first 2 and the second 2, or you can kind of just split the middle, where the sign of the third term goes with the second half. And then we're going to look for the GCF of both sections, so the first half and the second half, not together. So what would these two have in common? 1 and x.
That's 2.
X squared, correct. So I am going to put that x squared out front and divide both of these by x squared. What would be left? X plus 7. Then whatever that symbol was, whatever the sign was, you're going to bring that down and do the same thing for the second half. So what would these two have in common? 2. So you're going to put that right next to the plus, divide those both by 2. What would be left? X plus 7. The main thing with this is when you divide out the GCF on both sides, your inside should be the same. If they're not the same, something's wrong. So then, to write your answer, if these two are the same, you just write that once. That becomes one of your factors. And then the things on the outsides, the things you factored out, you group those together and put them in another set of parentheses. And that becomes your second factor. So these would be our answers. X squared plus 2 and x plus 7. And then to check ourselves, we could distribute it back out. So if I were to do that, x squared times x would give us x to the third. X squared times 7 would give us 7x squared. 2 times x would give us 2x. And 2 times 7 would give us 4. Usually in this case, there's nothing to... When we talk about our last set of factoring, you'll be able to combine like terms, but here you won't. This matches the original, so I'm going to... What questions do we have on this so far? So we'll start with the first example, then I'll let you guys choose some. So we're always going to split it down the middle. Oh, I didn't hit the button. What would the GCF of that first section be? 3x squared. So again, the dividing part that you're writing, you don't have to do that, but if it helps you see what you're doing, you can continue to do that. If we divide that out of both of the first two, what would be left? X plus, what was that last one? Not 3. So close? 5. There we go. Bring down your minus. The arrow is not necessary, I'm just showing you where it came from. And then what would be the GCF of these two? 2. And be careful because you're now dividing by a -2, so your signs are going to change. Yeah, x plus 5. You can almost assume what the other part is going to be, but don't at the same time. Make sure it actually is the right thing. So then if we're putting our two factors together, these are the same, so that's one of them. What would the other one be? Pick another one you want to see. 6. Yes. Is that what you were going to say also? Great minds think alike. Great. Same process. Split it down the middle. What do those first two have in common? X squared. So if we divide that out of the first two, what would be left? Y plus 3. Bring down your negative. What could we divide out of the second two? Negative 7y. So the negative was already brought down, but that is what we're going to be dividing by. So if we divide that out of both, what's left?
X to the power of 2 minus 7y.
Just this part.
Oh, that part? Sorry, I thought you were
Okay. Now we can talk about the final answers. What would our final factors be?
X to the power of 2 minus 7y. And then what?
Any others we want to see, do, go over, have questions about? And there are some on the back as well. Regina? And Alright, so starting with 10, there aren't any numbers, just variables. Same process, split it down the middle. So what do the first two have in common? A squared. We divide that out, what's left? A plus B. Bring down your plus. What do the second two have in common? B. If we divide that out, what's left? A plus B. So then what is our final answer? What are our factors? Questions on that? 12 is really the same, but it has a mixture. So what would the first two have in common? X squared. We divide those out, what's left? Y squared minus 3. What would the last two have in common? 2. Positive 2. And then bring that down. What would you get after you divided that? 1 squared minus 3. What would our two factors be?
X to the power of 2 plus 2. Y to the power of 2.
So this again would be an example when we were doing difference of squares. If you got something that was a perfect square here, y squared minus 4, y squared minus 9, 1, all of those, you would have to keep breaking it down. Are there any other grouping, or if you want to go back to the factoring, the basic trinomials questions that we skipped over that we want to see, do go over and have questions about. If not, for the remainder of class, you should be working on practice in this, Khan Academy. I would say try to get as much of the Khan Academy as you can done in this class time. Let me know if you have